for example, normally you would wear clothes and then you would stand in front of a mirror, you're trying how they fit. And so the cloth is able to show this, so if you move, the clothes are also moving, and it's showing you, for example, it's too short from this side, and like how you would normally. So for example, the next thing is, of course, it's a virtual reality mirror where you cannot really feel the stretch of the cloth. And here you can see it visually. So, and this is also something we're trying to test with the user. How? So for example, it could be the same cloth where you're in normal motion, it is okay, but when you stretch, for example, raising arms or picking something, it has a certain, Then the same functionality can be extended to different clothes. So your catalog can be as much as big as you want. Of course, we paid some attention to how to make the user interface here. So we also have an interdisciplinary approach to here. You can try different clothes, and you can try them. So that's basically the whole. Yeah. So another feature that we discovered, or from the user side, is maybe more immersion. So you could take a dress and wear it in different settings, and that is also an aspect that could allow the user to use this kind of applications more engaging. So it allows this application to be more engaging and hence more productive in the terms of being used for the problem that we are addressing. So you could change backgrounds, and this is something we found in different conferences and different workspaces that we trade fairs that we visited based on user inputs. These are the important features, and this is what we take. So this is our first prototype that we produced. Of course, so we can talk about the benefits of such a system. You could develop solutions like try before you buy. So the clothes don't have to be produced before they are even for the user or the buyer is there for them. So this is a benefit for the consumer. For the retailer or for the actual problem that we started with, it could provide a solution that decreases the return rate. So our initial studies, our initial interviews show that these aspects are important to decide more confidently that this cloth is for me. So to get the sizing. Of course, we have some limitations on fitting to the actual size. So we are testing with scanners and other techniques to more accurately guess the size. Not guess, but actually measure. So we have scanners that actually measure, but we have to work on them a bit further. In terms of technology, so what the architecture, what the key value that we are seeing here and what we're promoting here is that the way we produce the solution is scalable. Scalable in terms of you do not have to reproduce the same setup to get the same value in every instance that you have. So in one setup you saw it's an iPhone and a TV screen could produce the same results. Well, because the computation and all the other systems exist with us or in the central cloud, and the edge detection allows for the motion tracking, for example. The limitation, of course, it is not, so we do not see 100% convergence of people who try this. So not everyone is comfortable believing the data and what they see. And of course, we address this in our ongoing research, how to incorporate their questions and their needs into the solution to be more robust for those problems. For retailers, the process of digitizing clothes is not an easy process. So we see that around less than 40% of companies are using some digital form of production. It's digitized process in their production. So that means there's a lot of companies have to evolve to make digital clothes and versions of these into the production systems. And lastly, in terms of technology, that is something we are addressing heavily is clothing simulation is not cheap, which is also the benefit of our architecture, but it's still an expensive part of the solution to make it effective. And so those are the limitations. In future work, so this was one prototype, and what we are really aiming at is to develop a platform based on this prototype that takes research questions in terms of digitizing clothes, that takes different company processes and streamline them to the end user that they can try clothes digitally and basically incorporate them into e-commerce systems. That's the hope that the problem can be addressed much more effectively as well. So that's the future work is to scale this and to make it into a platform solution, because we also know from literature that this is not the first time. It has been tried multiple times, or for a long time. There's a lot of research that shows such solutions exist, but they exist as a unit solution, while what we are trying to do this time differently is to look at it as a platform, and maybe that has an influence on the outcome in the time coming. Lastly, of course, more users has to be integrated, and this is also the motivation for this talk. So we are looking for user studies. We want to include more data into our process. So we want the platform to actually address problems that exist from the user or from the broader community, rather than what we imagine in our labs. And that is also our motivation to be here. Yeah, so that was the talk. Thank you for this is our current prototype that we can do user studies with, and also engage the users to get more feedback that can help us develop this into scalable solution.
Thank you very much. Questions?
Have you thought about, or is there already something like more immersion via light or sound? So I could think if that plays a romantic scene, if I'm trying on a, I don't know, nice dress or so, you have even more immersion effects? Or something you do?
It could be something we could do. I mean, so we, of course, it might have an effect. What we were working on in the last is to stabilize the system so it can be used in such. But that could be something we can look at some point when the system allows. So at the moment, we have not considered more immersion than just changing backgrounds and changing them, or allowing the user to change them based on the clothes they're wearing. Which is not so right. So it's not very good.
First great work, it's really cool. Especially like the special stuff that was only for saying. What the question for me is like, how do you add new clothes basically? Because it's like, it seems like a lot of effort for every clothes is designed to be then 3D models and there's like some color splash input into the. It seems like a lot of effort.
Yes, it is a lot of effort. This is a whole part of industry that is in this space. The cases go for high value clothes. So a cloth that is mass produced, for example, would be one digital model that doesn't have to be reproduced. There are processes in Cloth 3D, for example, that does grading. So you do it once, digitize, and then you can do different sizes of it. It's an extensive process. We have a whole department dedicated to this, and it's not an easy process. That's I completely agree. But it is addressed in the software sense. So whatever benefits are going to be there, it will also see it.
It's also like really put a lot of effort in it.
Yeah. Okay. So yes. Thank you for your question.
Thank you.
That's why we bring the video, because normally we have to bring sensors and stuff, and through the airport we thought that would not.
The next presenter will be me. It's a incipient work regarding cellular glucose protection system. A few words about this incipient work. About the diabetes. So the main concern was about the diabetes systems that we can use to monitor the glucose level. The easiest one is a small piece of drop that we can take out on the finger to become faster to measure the glucose level. Some people don't like the needles, so it's not so nice to have a few times a day these needle drops in your skin. And other systems is to use sensors, somebody who needs monitoring all day, continuous monitoring. On the market, we can find a system that can be buried under the skin and monitor the glucose level on all day. So the main concern was to see if we can get correlation between the glucose level from the saliva and that we can measure from the blood. Another thing, it's about the cost. So we are thinking about what we have on the market, for example, non-invasive glucose meters. We can count here the non-invasive glucose meters which are using enzymes or special molecules which are bending with the glucose. And after that we can measure certain type of shifting in the optical spectrum. In this case we have used some sensors, optical sensor which can measure all these small shifts in the spectrum. We are discussing about spectroscopy, and we have, for example, round spectroscopy, where we have very, very narrow shift in the frequency. So another concern was to have something very easy. So for the system design, I used here an infrared LED, infrared detector, an amplifier stage, and after that, measured all this data and tried to extract this data and correlate it with a glucometer, regular glucometer from the blood. But in the end, I just took 10 patients where I know that some of them they had diabetes and they were under treatment. And I measured their glucose level using the classical glucometer and the glucometer, and after that with the saliva system. For the system, the electrical scheme, it's based on the system design. And this is the assembly. From a mechanical point of view, it's very important for the optical system to have a steady input and output, so the alignment from the optical point of view is very important. So I fit down the mechanical part and the emitter and the receiver. An early moving part was the cuvette, the 2 milliliter cuvette that is used usually in the spectroscopy equipment, and that can be filled out with the maximum 2 milliliter of liquid. And that one had a special spot. In the same spot it was placed every time that cuvette, so don't have different techniques. And now the measurement. These are the important part of the experiment. So I started out with 0 milligram per milliliter. It means that it was only saline solution, regular saline solution, and after that I just limited it with I made a solution with 50 milligram per milliliter of solution. These two values measured with the equipment, with the system. Here we have the intensity. The intensity here is actually the values from the ABC converter, the number of sequence of levels, and after that this one can be converted in the voltage level. But I left down here the positive integral values. It's much nicer for the graph. The measured value. The measured value is actually after I made all these concentrations. I tried to measure this concentration using a glucometer machine, and the real values are actually this one. So after I measure it, when you do all this mixing of the solution, you don't get exactly the right value. And because of that, we have some error in this measurement. Now the distribution. The distribution, so we have the intensity, and we have the measured value, and after that the real value. So the real points actually are really close to what we get from the saliva. Another problem is, how is the saliva? The saliva that we are taking usually must be taken in a certain time of the day. It must be clear, so you don't eat. It's like when you take it from the skin, from the blood. Usually take the glucose, the measurement before meal. So this measure must be done before the meal. For example, in the morning is the best day when you should measure the saliva glucose in the morning. And I did this for 10 patients. What we have here, so the saliva measurement, what I did with the equipment, and this one is the regular glucometer. This is the history of the patients. I already knew that these patient number, subject number 3, 4, 5, 6, 8, and 9, they were diagnosed with diabetes. And how was the measurements using with the saliva meter? I had the same measurements for the other ones, but the last one, prediction is, why is that? Around the value of 16, so I checked the value of 16 milligram per milliliter is the limit, well, where I have an accurate value, so close to the accurate value that the person is diabetes or is not diabetes. In this case, the value was 18, 54, and here I have 77 milligrams per deciliter. So this is the measurement that I get with the glucometer. The main problem is from these measurements, the patients, you don't know that actually the background of the patient. So if you have some problems, for example, living in the mouth, you can have different molecules as well in the saliva. So it's not a clear saliva. And because of that, we can say that the infrared measurement is the best one. So you have to know the background of that patient. So more measurements should be done with these devices. But for the incipient work, I can say that something is correlating between the saliva glucose and what we have in the blood. So further work can be done using more exactly, for example, the emitter and receiver can be used, for example, for a certain wavelength. So it's much precise to use maybe 2 or 3 wavelengths in the infrared spectrum, and after that to correlate all these values with this method. So thank you for your attention, and I wait for your questions. I'm sure who's interested in this biomedical stuff, but I guess that some of you are interested in it. A few ideas are always welcome. Yes.
Maybe a question. I love what you're doing because you're making something that's like more complicated, way easier. And what's very striking for me is that your setup it's clever, but relatively simple. So I asked myself like what is necessary to like bring this from research to praxis, because like this is like where most of the biomedical research like kind of never gets it. I don't understand this because it's like it seems great.
Yes, but you need, especially in the biomedical case, you need a lot of measurements. So I have only 10 measurements.
Yeah.
10 measurements is not good. And the main problem is that if you go, for example, to the hospital or the center, you need a special approval from the patient. So they must land you, of course, they just patient number 1, 2, and 3, you don't have the names, but usually they don't give you these. So the hospitals and the centers, they want to give you this data. So maybe research with an institute who wants to a common project, yes, they can give you a big database and you can work on this stuff. Yes.
So actually, there are many, all medical students need to do a doctorate, so probably just pass them the system and they'll do the research for you and get all the data. Maybe.
If they are alive, yes.
Yeah.
Yes. And I told you another problem is the saliva cleaning. So you must be sure, so you measure that saliva with the different systems and make sure that you don't have maybe that error that I had in the last part for this. Maybe it was something was very big. The difference is big, so you can see 77 milligrams, and usually the limit is around 100 milligrams for a good glucose level in people. Yes.
Do you trust the hardware to scale? To give reliable results for more readings?
Yes.
You take the hardware and reproduce it multiple times a day?
Exactly. So the same setup, So the same setup, I made the measure more times, so not only, this is another thing that you have to do the measure more times. And from the optical point of view, in the end, you have to place everything. Exactly. So the optical stuff, you don't want to move the optical stuff. So everything is aligned. So that was another part that is the next.
If you could reproduce this setup again.
Exactly.
The same.
Exactly. So 3D printing, alignment, and everything. Yeah, you can do it.
Maybe you know, but the ADC and the Arduino is just a crappy one, so if you
Exactly.
you might invest in a bit better ADC
Exactly.
to get.
Exactly. So the resolution is you're going to have only 10-bit resolution, so you can go up and the amplifier stage, the current voltage amplifier can be used the better one, and everything good. It was only an incipient research to see it's working, it deserves more investigation or just. Yes.
Will you ever make it into a startup?
Sorry?
Will you ever make it into a startup?
To stop.
Spin-off.
Spin-off. No, I didn't think about it.
Thank you.
I will handle the word with our next presenter. It's ACDSA. Okay, and this paper is why Bitcoin is so original and why it's published by ACDSA. So the floor is yours.
Hello everyone, my name is Saeed Mustafa. Saeed means happy in Lebanese, and I'm happy now to be in Seychelles with my wife. It's like a new honeymoon.
Wow. So, first of all, I'm not sure why you are here now. If you are here, so you shouldn't be here. So if you want, you can go. The paper is presented.
I'm a civil engineer and business international engineer from École Centrale de Nantes in France. And I work in family business that's in code refining and recycling. And I also teach Bitcoin and blockchain at St. Joseph University. My wife Tina is the communication and computer engineer, and she is associate professor at the University of St. Joseph in Beirut. Today we will talk about Bitcoin, about its originality, not only why Bitcoin is a new treasure that travels the globe without needing permission, and that it reserves its value, but also the essence of its originality, as it's detailed in our paper. And we will delve into why its imitators fall short of capturing its essence. Picture this: in 2008, there was a financial crisis in the world. Banks were going bankrupt, and many currencies were devalued. Even in Seychelles, they told me, the tax driver, that the Seychelles rupee lost a lot of its value. And in these times, in these crisis times, there were a person, an innovator, who thought that we need to go back from the fiat currencies. We need back a hard money that confirms its value and that it's really backed by energy and not printed out of thin air. I will talk a little bit about the history of money. First, the money we needed money to trade. Firstly, we used the barter system, and then people long ago traded with shells and salt. And after that, they used gold and microns. Gold were better than shells because shells lose faster their values because you can easily find them and create them. But gold is hardly found, it's really rare, so it's hard. So it was a better version of a money. And then, after the gold standard, it's become very hard to carry gold and take it to long distances. This is why we needed paper money. This is why the governments started to put gold in their treasuries and print money as a receipt of their gold funds. And in the Bretton Woods system, that was the case. The dollar was linked to the gold, but then the government started printed much more money to finance wars and to finance their system. So that's why there were a financial crisis, and after that there were cryptocurrencies, and there were Bitcoin to solve this solution. So Bitcoin is not just money, it's a freedom from central control and towards a world with hard money. I will talk a little bit how Bitcoin works. It's a peer-to-peer network. Every transaction is safeguarded by cryptography. Every person can send Bitcoin to another one without needing the permission of anyone and without trusting a central authority. There is no central authority in Bitcoin. All the transactions that are broadcasted, the miners take them and try to solve a puzzle in 10 minutes. It's a race across the world between all the miners. And the first miners who find the block, who solve the puzzle, create the block and broadcast it to all the nodes. And then the nodes verify that it really did a hard work, that it really that this miner really finds the solution of the puzzle, and it really used a lot amount of energy. And then the consensus is arrived, and so it's very hard to change any block in the blockchain because every block is linked to the next one, and if you want to alter any block, any previous block, we need to do all the work from the previous blocks to now. This table shows the top 10 cryptocurrencies in the world since 2013 until now. You can all see that Bitcoin was always the #1 cryptocurrency. Although a lot of cryptocurrencies were made, and although Bitcoin code is open source, so anyone of you can do the Bitcoin, can do similar as Bitcoin because it's open source on GitHub. You can just copy it and change some features, change the name, and you have another Bitcoin. So a lot of people did that, and maybe they changed a little bit of the scalability problem that Bitcoin had, because Bitcoin focused on decentralization, and even they changed this, they couldn't compete with Bitcoin. And in this article, we will delve into why they couldn't compete. The risky insights of Bitcoin is that Bitcoin was born to make the money fair and to make a world with no corruption, with no central authority that can corrupt. So no middlemen. It had no value. When it started as a hobby. It had no value. No one believed that there is one day Bitcoin will be worth something. So everyone joins the network organically, and it grew organically, step by step, without anyone trying to mine a lot of Bitcoin because he wants to take them for himself. And the key insights of Bitcoin that once the miners are joining from the beginning, the network becomes bigger and is growing. So once the network is growing, there is more incentives that everyone joins this growing network and not a new network that will be easily attacked. And there is a 51% attack that is easily done on a small network. As I was saying, Bitcoin has the most security because it was the first coming. So usually, if let's say if you want, let's ask any one of you, if you want to store your money, your wealth, in something, you have hard-earned money, and you don't have a business to invest in this hard money. You want to store it. Where to store it? Anyone can tell me? No? What's it? Excuse me? Buying an asset. Buy an asset. Yeah, for example, you can buy a real estate, but when you buy a house, you tie yourself in a local geography. So you are tied to the local politics, to wars, to anything in this place. So if war happens or you want to leave the country, you cannot just take it with you and leave. You have to sell it, to find buyers, and so it's hard. And if you want to keep your money stored with the current currencies like dollar or euro or anything that is burned by inflation, it's like you are buying a nice ice cream and it's melting by the sun, like the inflation melts the dollar and euro. So it's usually better to store your value in an asset, for example, but as you were saying, the asset is tied to local geography. So better to you to store it in something hard and something movable. You can easily take it with you. For example, now if I have bitcoins and I'm in Seychelles, if all my money are in Bitcoin, I don't care what happens in my country, in Lebanon. I don't care I care, of course, but for money, I don't care. So, because I have access to my money wherever I am, okay? So, and the other thing that Bitcoin has a network effect, because it started, so every exchange starts selling Bitcoin, buying Bitcoin, so you can easily trade it. It has liquidity, volume. Even now in US, the ETFs, BlackRock, Fidelity, all these funds started selling ETFs for Bitcoin, so it's easily accessible. And ownerless, Bitcoin's creator, Satoshi, was anonymous, and he disappeared. No one knows who is he and where is he, and we don't care because it's an open source software. We can all use it, and we all, as a community, decide of its future evolution. Okay, imagine a world where it's free from monetary control from banks and governments. This is what Bitcoin is building, and countries like El Salvador are leading the way. That they did Bitcoin legal tender, so now people in Salvador uses Bitcoin as hard money instead of a money that can be easily printed. And I just want to recap at the end the differences between fiat currencies, Bitcoin, and other cryptocurrencies. First, fiat currencies are centralized. There is data in a small place, and they can alter it. They can give money for free for someone, and it can be corrupted. No one will know. Bitcoin is decentralized. Anyone can join the network, anyone can leave, and anyone can use it. And other cryptocurrencies are trying to trade off this decentralization to scale, to make it more scalable. The Bitcoin is fully transparent. The blockchain of Bitcoin shows every transaction happens from the start from the beginning to now, till now. The fiat currency have government control, but Bitcoin is censorship resistant. For example, if I want to send money to someone else, I can without taking permission of anyone and without letting anyone decide if some people can say just because I'm Lebanese, maybe I'm in a country that has desert, I'm a bad country, but we don't have desert in Lebanon. Lebanon is a very beautiful country, not like it's publicly, it's bad publicity. So no one can decide who can send money to anyone. It's basic human right. The fiat currency has inflation, Bitcoin is supply. Other cryptocurrencies are always changing because they have like a tech companies, they have marketing teams, they have development teams, they're always changing the protocol. There's no immutable protocol. Fiat currency is backed by trust. It's long ago, since 1971. It's not backed by gold anymore. But Bitcoin is backed by the largest computer network. Fiat currency created of thin air, Bitcoin created by energy, and the fiat currency is financial slavery tool, but Bitcoin is financial freedom tool. And other cryptocurrencies are vulnerable to government attacks. So as we stand now at the dawn of this financial revolution, we are left to think that maybe Bitcoin is gunpowder of this era. Any question?
We are waiting for questions.
So, did you invest in Bitcoin?
Yes.
Okay. Because you're passionate, so.
Yeah.
So you're doing well with Bitcoin.
Yeah.
Okay. So.
Thank you.
All right. Thank you. Thank you. Our presenter is Amir Dahi, and his paper is Towards Lightweight Transport Architecture, an analysis on semantic segmentation.
I'm sorry.
Okay, absolutely. Okay, so sorry. Yes.
If you have a follow-on project and you're looking into more immersion or emotion detection or anything, let me know. So I have a colleague who might help you.
Yeah.
Yeah.
Okay. Yeah. I have. Okay.
Thank you.
So thank you guys. Thanks so much to be here. Actually, I know that was too hard for this last session. Today I will present the work of my team, actually with the students regarding the acceleration of the inference of semantic segmentation, especially when we use transformers. Why we would like to actually do an inference acceleration? Actually, one of the main problems regarding when we go ahead for the deployment in industrial applications of the artificial intelligence or natural learning architectures came from the fact that it costs too much because of the hardware, the GPU that's must be used in order to do the deployment. In order, if you like to reduce the cost of your software or your model to deploy, actually you need to use small GPU. Actually, to give you an idea, when I started with the company Cyclopic AI in 2018, when we deployed our first water classification model for tolling, actually it was like prices was 10,000 euro in order to deploy only the small model for the protection. Right now, of course, the cost is reduced. It's actually one GPU like the T4 and NVIDIA T4 is around 2,000 euros. But between that, it's always too much because if you are in concurrence with other classical methods, you don't need GPU. It means that always the cost is more or increased. So the idea now, if I would like to reduce the cost of my, if I have good resource. Keep in mind that we are in an industrial case, and in that case, what is the cost? Okay, I can enhance the performance, but if the cost is too much, is too high, we will never sell anything. So now, from an academic case, now the idea is how to reduce the cost. Reducing the cost, it means we can train the model whatever we want. I am just working about inference. I don't care about training. You can train whatever you want. You can take 1 month, 2 months, it's okay. But when you do the inference, you need to be quick and use very small hardware. In that case, you would like to reduce the size or accelerate actually the inference. That's the most important thing. What we see that actually that during all these several years, we know that the size of the models increase in exponential. Okay, and then without talking about LLM. But actually, in the past models, we are now about more linear parameters. So then we have also another thing that we know that here you have the number of operations that are needed actually in order to do number of operations actually that are needed in terms of flops per model. And we see also that in this case, even that, the number of operations increases. So now, in that case, there's this new topic in artificial intelligence called acceleration, and what are the different techniques of acceleration of the methodology to deep learning. We have, I had these levels. We have in the hardware level, we can start by modifying FPGA. Someone we can use FPGA, ASIC, GPUs. We can modify the hardware in order to increase actually the inference. There is also software accelerators that are the compilers, right? The graphical base that others actually compile through Tino, otherwise use Tino or the one of Intel, otherwise NVIDIA also use their own compilers. You can use also optimization of algorithm complexity. In this case, what we do? Here, the idea is to reduce the number of operations and use the full parallelism of our hardware. This is actually what it is. And then you have the classical, also other techniques, optimization of the network architecture. We can reduce by using what? Using pruning, network and NAS, the architecture, in order to reduce have the smallest, to have the smallest architecture. Here in this work, we focus on this case, how to reduce the complexity of our algorithm or our architecture. It means the transformer. We know that the division transformer gives very good results actually in the semantic segmentation, the object detection, the classification. But when we go through the deployment, we know that even for real time or for embedded systems, it's too much complex to do that. So idea, how can we accelerate that? I first think that to give you an overview, I think it's already presented, but this is classical segmentation-based, semantic segmentation-based model. This transformer that was published in 2021. Here, we know that we have two blocks. The first one is the transformer encoder, then you have the task transformer. Actually, in this case, here the image is decomposed on different parts, and each part is sent and parallel. Okay? This is actually at the inference you have. What we do is only maximize the upsampling to obtain single class per pixel. This is actually what's done in this architecture. So now, how, if you would like to use it in an embedded system, how can we do it? Now, how to reduce also the complexity of our architecture? The first thing, what we do is we did only a small analysis of the correlation between the different layers. In order to check, okay, if there is a correlation between layers, how to exploit that? It means that there is some redundancy, but then it means that I can compress my model. So, we used different, as we can see, here where it is only dark, there's very large, small correlation. When we have very light, it means that there's a big correlation between layers. And in this case, we see that we have a lot of redundancy. This is the first area. Then we can see, give you another view of this redundancy by using, for example, correlation matrices. And then we see we have the correlation scores, and then we know that there is actually between layers, we know where there is a correlation or not. From this side, we can define just a small threshold in order to reduce, to compress different layers. This is the idea. This is then, if I would like what you propose, first we replace the classical mechanism of attention map with two things. The first thing is skip attention, and the second is we added the pull and pull attention. How? We did that. First thing, at the encoder, what we do, we exclude the multi-layer attention separation from layers where there is a correlation. This is the first thing. Very simple. We only just add skip connections. And then it means here we will only focus on the NLP computation. That's it. This is the first thing. Then the second idea that we have we do pooling over Q, K, K, and V tensors. It means why we do that. We unpool, then we apply our computation in parallel, then we add simple also, and then we restore our. Now, from this, what we obtain after this only small operations, first thing, we test on two data sets. The first one is ATP20K and statistics. You have the that are available. We have this two sample data sets that are available. Obtain the results. What we can see that for this segmentation T16 with pool and coordination, we have increased the frame rate but with 14%. But here in the E20K. And then even with T16 with skip attention, we achieved more than 26% of the frame rate. Okay? And then if you go to the city map for cityscapes, we have more than 70% of increase. And then also for the other, actually, when you increase with the mask at 16, we had more than 100, double actually number of frames per second. This is actually what we had according to our goals and limitations. Of course, I can show you quickly some illustrations regarding the results. We have the contour. This is actually, you have the first results actually without any optimization. Then with pool and pool attention, and this here with skip attention. And then we can see that the results as very here we have the contour, and then we are even better in some cases than the classical model. So actually, in the case of the cityscapes dataset, we can also observe the same. We have the same observations, but we can conclude that our proposed mirror is very simple, very detailed in case of transformers. Only two operations that we can add to our architecture, and we can bring many very good acceleration in terms of the effort. So we could conclude our here skip attention block, pool and pool attention are very good alternatives actually if you would like to use transformer for semantic segmentation. What we can also add that skip, we allow also to have an acceleration of the model appearance. We have also the pool and pool model that was also used in other cases, in other models. These two techniques can be also used in other architectures, of course. And then this we can have that there is no decrease in the accuracy. This is very important. The idea is not to decrease the accuracy by keeping at least the same accuracy with accelerating the inference. What we would like in our future work actually is to use the cross-entropy loss and the polar Hausdorff loss also or inverse from loss in order to increase the performance. And then also we would like to do some optimization in segmentation attention network, and then with linear attention approaches. So thank you for your attention.
Thank you very much. And we have questions from the room.
Sounds nice. Why are you at a conference and not directly in the journal?
This is just I think we will submit to the minister. Thank you so much.
Thank you.
Thank you.
And our last presenter is Lebohan Rarika Latala.
They presented before. They
The last and the strongest.
I will handle the first Okay, thank you very much for attending the session.